The Sikorsky S-70UAS U-Hawk represents the pinnacle of innovation in rotorcraft technology, transforming the world's most reliable utility helicopter, the Black Hawk, into a fully autonomous unmanned aerial system, UAS. This ambitious project is not just about eliminating the pilot, but also about leveraging artificial intelligence to achieve performance and safety impossible for manned systems. The Sikorsky S-70UAS U-Hawk represents the pinnacle of innovation in rotorcraft technology, transforming the world's most reliable utility helicopter, the Black Hawk, into a fully autonomous unmanned aerial system, UAS. This ambitious project is not just about eliminating the pilot, but also about leveraging artificial intelligence to achieve performance and safety impossible for manned systems. Nose cargo door and ramp. A key feature is the installation of a clamshell door and powered cargo ramp in the nose section. This innovation creates a unique flow-through loading system, allowing for fast and efficient loading and unloading of cargo. Increased capacity. By eliminating the cockpit, the U-Hawk gains up to a 25% increase in cargo volume compared to the standard Black Hawk model, enabling it to carry larger, logistics-oriented payloads. UGV access. The nose ramp also facilitates integration with uncrewed ground vehicles, UGVs, allowing the UGVs to drive on and drive off, enabling the U-Hawk to function as a transport platform for robotic systems. The U-Hawk's fully autonomous capabilities are powered by Sikorsky Matrix technology, a proven open hardware and software architecture. Matrix is the brain that enables the helicopter to operate all phases of flight without the need for a human pilot. Intelligent flight control. Matrix integrates sensors, a mission computer, and a third-generation fly-by-wire system to provide highly accurate and responsive flight control. The system can autonomously handle turbulence, sudden wind changes, and minor technical issues. High-level mission planning. Operators simply specify waypoints and mission objectives through an intuitive tablet interface. Matrix will automatically calculate the optimal flight path, including safe altitude, fuel usage, and obstacle avoidance strategies. Safety and redundancy. At the heart of Matrix is high system redundancy, ensuring that the failure of a single component will not result in loss of control. This is critical for autonomous operation in unstructured environments. By eliminating the need for a human crew, the U-Hawk can maximize the Black Hawk's operational potential. Flight duration and range can be significantly extended. Long-range flight. The U-Hawk can be configured with significantly larger internal fuel tanks due to the removal of the cockpit. This allows it to have a claimed ferry range of over 1,600 nautical miles, or an on-station time of up to 14 hours. Danger zone operations, forward-line logistics missions, ammunition transport, or medical evacuation in contested environments can be conducted without risking the lives of expensive and difficult-to-train personnel. Heavy logistics support. With its maximum payload capacity, the U-Hawk is capable of supporting heavier combat loads. Reports even mention potential configurations for carrying rocket pods, such as HIMARS or heavy guided missile munitions. The S-70UAS U-Hawk is a key component of future defense vision, particularly within the Distributed Maritime Operations (DMO) and Joint All-Domain Command and Control (JADQ) concepts of operations. Multi-mission platform. Beyond logistics, the U-Hawk is designed to be an adaptive platform. It can act as an aerial mothership, carrying and deploying swarms of small drones for reconnaissance or distributed strikes. Reduced personnel burden amid pilot shortages and high training costs. The U-Hawk offers a solution to augment air power without the need for additional manned personnel. Risky and tedious missions can be outsourced to machines. Rapid response and flexibility. Due to the absence of human physiological limitations, the U-Hawk can be launched at very short notice and operate in extreme environmental conditions or for extremely long flight durations. Sikorsky has demonstrated the maturity of the U-Hawk technology through a series of successful flight demonstrations. This program focuses on validating autonomous capabilities under realistic conditions. Elias demonstration. The U-Hawk's development is closely aligned with DARPA's Elias Aircrew Labor in Cockpit Automation System program, which aims to enable autonomous flight of a manned helicopter. The U-Hawk takes this a step further by eliminating the cockpit entirely. Complex mission testing. Demonstrations have included autonomous flight in obstacle-congested environments, unassisted landings in unprepared zones, and complex flight maneuvers to avoid threats. Rapid integration. The U-Hawk's advantage lies in its construction on the S-70UAS airframe, which is already in service worldwide. This allows for relatively rapid integration and lower operational costs for operators with existing Black Hawk infrastructure and supply chains. The S-70UAS U-Hawk is more than just a helicopter. It's a statement about the future of air mobility, where robotics and artificial intelligence are taking over the most challenging and dangerous operations. Would you like me to explore current developments or potential users of the U-Hawk? Sure, I'll expand on the Sikorsky S-70UAS U-Hawk narrative and organize it into 5 more detailed and in-depth discussion points.